Hi, my name is Ruan here. I'd like to share with you our experience about implementing a security management system for OpenStack. Its objective is to enable the multi-tenancy that we often talk about in the community based on Keystone. Based on several surveys, one of the main reasons why enterprise customers don't want to migrate their cloud migrate their IT system to cloud is that they are afraid of losing controls over their data. And one potential solution to resolve this problem is to have a security management systems that can control and protect their data in the cloud infrastructure. Here, let's take a look at a use case, multi-tenancy use case. For example, we have an enterprise client which has several departments in this enterprise. At the same time, for each department, it is affected with a set of resource pools that it can use, it consumes. And if we want to put all these systems to cloud, and usually we need to protect these systems based on three aspects. First, the security management system should show that it protects their data in the data centers of the provider. Second things, the enterprise clients can have controls to administrate these security management systems. The third thing is that for some critical data of the enterprise clients, they like to keep it in their hosted in their local site. And the security management system should also, based on this information, to remotely protect their assets in the cloud infrastructure. And in order to achieve this use case, normally for a security management system, it should have two parts. The first is a security policy definitions, means that the customers should define their security policies, which kind of data they should protect, The second thing is the security enforcement system. This means that they should implement several security enforcement mechanisms so that this mechanism can protect their data in the cloud infrastructure. And for all these programs, based on our research, the main key issue is to provide access control modules which can define and configure the security policy. For those who don't really understand what access management modules are here, I just have a brief introductions. For access control modules, usually it contains several parts. The first is an access control models. Usually, for example, in Linux, we have the ACL, MLS, DTE, or role-based access control models. And based on one access control model, we can define our access control policies. For example, an administrator of the customer can use rollbacks to define different roles that it can use and affect different privileges to these roles. When we have the access control policy, the third step is to provide a set of access control enforcement mechanisms. In the case of OpenStack, for example, in Keystone, we have a native authorization mechanisms, and for neutral, we have the network APIs that we can use to enforce these policies. We have a firewall as a service extensions, and at the end, maybe for some critical data, we can provide a encryption solutions for these data. And there exists a standard framework of access control, which is called XACML. Here on the left side, on the right side, there is an introduction about these frameworks. We have the PEP, which is a enforcement point to enforce the policy decision. We have the PDP to make our decisions. We have the PIP to gather information, and finally we have the PAP, which can administrate and configure policies that PDP used. And this is a standard framework that we used for access controls. And if we apply this framework to cloud computing, they may have some changes because cloud computing is a little different from the conventional systems. The first, for the PDP, instead of using a centralized PDP that can make a decision for all the requests, in our use case of multi-tenancy, we should have several PDPs and several sub-PDPs. Well, each sub-PDP make decisions for one tenant. The second thing that we should take into account is a migration from the provider-centric to user-centric. For example, in the operating systems at Linux, as a provider, we provide access control modules for all the users that use these systems. But for cloud computing, it's not the same thing. Because for cloud computing, when we design the system, we don't know how user will use these systems. For example, when in one tenant, maybe we use a role-based access control model. So in another tenant, we use a multi-level security model. And in this case, and sometimes we will create a new tenant which will be applied with a new access control models. In this case, we think that our security management system should also be pluggable, means that we can add some new sub-PDPs to this framework. Second thing is that customization. When a tenant apply an access control model, it should also be possible to configure the policy that is used for these access control models, and the administrator of the tenant can configure based on their own requirements. And for our implementations, we have a meta model called EMTCA. With these meta models, it can support several different access control models exist, as I mentioned in the previous slide. And then the most important things for this meta model that, at one hand, this meta model can be used to customize access control policies for each tenant, which will control the access within one tenant. In the other side, we also believe that the inter-tenant collaborations is important. This means that one tenant can share a set of resource with other tenant, and we need some kinds of inter-tenant access control policy that to control this inter-tenant access. The last things which is not taken into account in Keystone is the administration part. This means that we should also define which are the users that can create new privileges, can create new roles, and do they have the right to affect these roles to other users. And this is another part that we have taken into account in our security management system. Here is the architecture of our implementations. On the right side, we have the OpenStack platforms, and we add two hooks for each service, for the Nova service and the Keystone service. These two hooks can redirect all the authorization requests to our platform called Moon. In Moon, we have different models for inter-tenant and intra-tenant. And an interesting thing that in Moon we also have a graphic interface through which custom administrators can configure, can add, can define their policies that used in Moon. For the integration to the current OpenStack platforms, we have added a filter in the pipeline of Keystone and Nova. And another important thing that, as I explained, one objective for our framework, our management system, is to provide on-premise security management systems which will use some local data of the enterprise client. And the second objective is to have a system that administrator of the custom can configure, define their policies through the graphic interface I've explained it. The third thing is that when the end user of the custom use their systems, they are protected by these security management systems. And this is our first step for a security management system for OpenStack. We have our Moon, the access control modules which is in the central. Later, we integrate these frameworks with native Keystone authorization mechanisms. And then our next step is to integrate this work with other services in OpenStack, like the neutral APIs, framework as a service, the storage, and Novas. And the last step that we plan to do in the future is to add some complementary security modules that can provide the advanced protection controls over the OpenStack platforms. This is my presentation, and if you have any questions about these security management systems, you can contact me. Thank you.